Hello everyone, I'm Matthew Ho.
I'm Kevin.
My name is Andy Vuong.
And I'm Michael Tang. Here's a tutorial for Chapter 18, pages 512 to 520. Climate change. It is a phenomenon that is constantly changing, so we have to look at its past, present, and future. While it is easy to measure a climate's current condition, it is much more difficult to measure the climate condition of the past.
Because the past is, well, the past, it is impossible to directly measure the conditions of that time, so scientists use proxy indicators, indirect evidence of the previous climates. They serve as indirect indicators of the atmosphere composition, temperature, and even the weather of the past. Ice cores may be some of the most recognizable proxy indicators, but sediment cores, coral reefs, and tree rings are also proxy indicators. Despite their usefulness, a proxy indicator only reveals regional information, which is why scientists use multiple proxy indicators to create a global perspective of the past. On the other hand, the present-day climate is much easier to study, since scientists can directly measure and monitor the environment, such as Charles Keeling's documentation of global carbon dioxide levels, showing a dramatic increase in carbon dioxide concentrations in our current atmosphere.
Scientists use climate models to combine knowledge of atmospheric properties and ocean interactions in order to simulate climate processes. This requires modern computers and more advanced equipment due to the complexity of the processes. Researchers test the effectiveness of climate models by using past climate data. In the figure above, scientists test climate models by integrating both data from past years represented in blue lines and actual observed data represented in red lines. Both natural and human factors contribute to climate dynamics, and these climate models help to produce reliable predictions. Models that incorporate only natural or anthropogenic factors will not be as reliable as models that integrate both. Overall, scientists use models to help humans understand the climate, how it changes, and how climate systems function.
Ever since the beginning of the Industrial Revolution, climate changes have had negative effects on us worldwide that will only grow more severe over time. In 2007, the IPCC released its fourth assessment report, which summarized thousands of scientific studies and addressed impacts of current and future climate changes and how to pursue them. Temperature change is a global indicator about how climate change is affecting us. The 11 years from 1995 to 2006 were among the 12 warmest years in record. What does the warming of temperature do to us, you say? Well, when the climate is warmer worldwide, the polar ice caps and glaciers begin to melt as they are exposed to more heat. As it melts, the water is added into the ocean and leads to increased sea levels. Rising sea levels mean that people who live on islands or along the coastal region will have to relocate because their homes have been submerged into the sea.
We have experienced the warmest days in the past decade, with the Arctic region being the area most affected by this. The permafrost melting causes destabilization of the buildings around that area. The Inuit people and polar bears are losing their home. Polar bears swim for miles and miles, but with no ice for them to rest on, they eventually drown. The higher sea levels and the currents being out of balance causes stronger storms and bigger hurricanes that not only last longer but are also more powerful. Now, at higher altitudes there's higher precipitation, and in mid and lower altitudes there's less precipitation, causing drought, and there's flooding and water shortages that are just off in different parts of the country.